Hello students. Today I will solve problem 16 of chapter 5. This is the last chapter of our course. You can see the statement of the problem on the screen. A bullet is fired straight up with the initial velocity, initial speed v naught dash, assuming g is constant and ignoring air resistance. Show that the bullet will hit the ground west of the initial point of upward motion by an amount 4 omega v naught dash cube cos lambda over 3g square, where lambda is the latitude and omega is Earth's angular velocity. As mentioned in the statement of the problem, the bullet is fired in vertical upward direction, in z-axis, and the initial velocity initial speed is v naught dash. Assumption is that there is no air resistance and g is constant. We have to show that the bullet will hit the ground west of the initial point of upward motion by an amount 4 omega v naught dash cube cos lambda over 3g square. So as mentioned in the problem, lambda is the latitude and omega is the Earth's angular velocity. So the bullet was fired in z direction with velocity v naught dash. So along z direction, this is the velocity, and so along x direction or y direction it is 0, as shown here. The initial position of the bullet is origin. That means x dash 0, y dash 0 and z dash 0, it is equal to 0. In time t, the position of the bullet in all three directions can be found using equations 5.4.15a. It is mentioned in your book. With the same equation number, you can refer to your book. And 5.4.15b and 5.4.15c. So this is equation 5.4.15a, 5.4.15b and 5.4.15c. So these are the equations which are also mentioned in your book Analytical Mechanics by Fowles. So using 5.4.15a, this is the equation. So if we put the value of x dash 0, x dot dash 0, y dot dash 0 and z dot dash 0, if we put these values in this equation, in equation number 5.4.15a, we will get x dash t, which is equal to 1 over 3 omega gt cube cos lambda minus omega t square into v naught dash cos lambda minus 0 dot sin lambda. So this 0 you see, this is y dash here, this term is y naught dot dash. So this is 0, its value is 0 as we calculated in the previous slide. And similarly this term, its value is also 0, as I shown in first slide, its value is also 0. This is the position and this is velocity. So finally we get x dash t, which is equal to 1 over 3 omega gt cube cos lambda minus omega t square v naught dash cos lambda. So this is equation number 1 in this problem. So now using equation 5.14.15b, this equation, and now we will put the value of, because this equation includes x velocity component, y velocity component, and y position. And you know that we have values of these. So if we put the value of x velocity component and y position in above equation, so we know that its value of velocity along y direction is 0, the value of velocity along x direction is 0, and the position, because it is on origin, so it is also 0. So finally our y dash t, it is equal to 0 here. So now we will use equation 5.4.15c along z direction. So z dash t, this is the equation, which is equal to minus 1 over 2 gt square plus z naught. So this is the velocity component along z. So we have z naught dash z dot z naught dash t plus omega x naught dot dash t square cos lambda plus z naught dash. So now we will put the value of velocity along x axis, velocity along y axis, and the position at z. So now we will put these values in above equation. So after putting the values, we know that the its value is 0 here, so that's why it is 0 here. Similarly, z dash, it is also 0 here, and this term, this is equal to v naught dash. So we simply place the values, and our final equation is z dash into t, which is equal to minus 1 over 2 gt square plus v naught dash t. When now the case is when the bullet hits the ground, z dash t, it should be equal to 0, because now it is on the ground. So this equation 3, it becomes 0 equal to minus 1 over 2 gt square plus v naught dash t. So from here, from this equation, we can calculate time when it hits the ground. So gt equal to, this is just simplification, gt equal to 2v naught dash, and from here the time is equal to 2v naught dash over g. So this is the time. But we have to show that the bullet will hit the ground west of the initial point. So at the time when bullet hits the ground, so let us check x dash t from equation 1. So x dash t, it is equal to 1 over 3 omega gt cube cos lambda minus omega t square v naught dash cos lambda. So this is the equation 3. Now we have time, so we will simply put the value of this time in above equation, in equation 3. So we get x dash, sorry, in equation 1, this is the equation 1. Yeah. So we get x dash t equal to 1 over 3 omega g, so this is the value of t, which is 2v naught dash over g, and this term includes cube cos lambda minus omega. Again we place the value of t here, whole square, v naught dash cos lambda. So this is just simplification. After simplification, we get x dash t equal to 8 omega v naught dash cube over 3g square, this term cos lambda, minus 4 omega v naught dash cube over g square cos lambda. This is after simplification. Now x of dash t, it is equal to 8 omega v naught dash 3 cos lambda minus 4 into 3, this is 12, omega v naught cube cos lambda over 3g square. We just simplified it, and after simplification the x of dash t, it is equal to minus, because this is 12 and when we subtract 8 from the 12, so we get minus 4 omega v naught dash cube over 3g square cos lambda. So in this equation x dash t, it is negative. You see here, this is the negative sign, which means after hitting the ground at time t, the bullet had fallen to the west. The distance between initial and final position is this. So this is the distance between initial and final position. So yeah, this was problem 5.16. In the next video lecture I will solve problem 5.17, which is actually the next case of the same problem. So for that you have to refer to the next video lecture.